Unit 2, Lesson 2 video in Integrated Math 3 video series. In this lesson, we're going to talk about difference of two squares and how to factor using that method. Before we get into that, let's do these 4 warm-up problems and see what you can do there. All right, so in number 1, going back to our last unit, factoring with an a value that's 1, we don't need to do factoring by grouping here. You can, but it takes a lot more time. What we can do is just set up our 2 parentheses and think about the reverse distribution. X times x gives us x squared. And then we're going to think about 2 numbers, of course, that are going to end up having to multiply to give us 5. But then if we think about the 2 in between steps, they're going to have to add to give us 6x. So that's going to be x plus 5 and x plus 1. In number 2 here, when we multiply this out, we're going to get x squared times x is x cubed. X squared times negative 6 is negative 6x squared. And then we're going to end up having a 5x and a negative 30. So in general, we can think about it this way. A quadratic times a linear will always be a cubic. So that's one way you can kind of think about that. What is the slope of the line 3x plus 9 equals negative 17? So this is not in slope-intercept form, so it's hard to tell just by looking at it this way. So we can solve for y here. So 9y equals negative 3x minus 17. And then to get y by itself, we're going to divide by 9. So everything divided by 9. So negative 3 divided by 9 ends up being negative 1/3. And then negative 17 divided by 9, we can just write as a fraction there. So our y-intercept is here, and our slope is here. So the slope of this line is negative 1/3. All right, then lastly, and this is really going to help us with our lesson today, is just reminding yourself of the perfect squares. So 1 squared is just 1. 2 squared is 4. 3 squared, 9. 4 squared, 16. 5 squared, 25. 6 squared, 36. 7 squared would be, I'll just hop over here, 49. 8 squared, 64. 9 squared, 81. And 10 squared is 100. So just having those in the back of our mind and knowing that these are special in some way is going to help us today. So keep those numbers in mind as we go throughout today. All right? So our goal for today is to factor difference of 2 squares, as I've said already, but also to use difference of 2 squares to multiply 2 numbers. So we're talking about like a mental math strategy here that will take advantage of this difference of 2 squares idea. And then lastly, use difference of 2 squares to understand how to maximize area. And you'll see what I mean at the end of our lesson today. All right, so if we look at difference of 2 squares. So I really want for you to understand like why this whole process works. So I've got difference of 2 squares here. I've got something squared minus something squared. That's the difference of 2 squares. I've drawn a picture of what this is. So we're subtracting the larger square minus the smaller square. So that should leave us with all of this area in here, right? If we subtract the larger one minus the smaller one. So we really want to think through like, what is this area in red? And we can do that by examining and breaking this up into these 2 pieces. So we have this rectangle plus this rectangle should be that red area that I was describing a minute ago. All right, so let's think about what the length and width of this rectangle here is. The length here is x. The width here, this length right here, is x minus y. All right, if we take x minus y, we're left with this piece here. So x minus y is this length there. So the area of this piece is x times x minus y. All right, let's look at this piece up here. This length right here is y. And then, of course, the whole thing is is still x. This length right here is going to be x minus y. So the area of this rectangle is y times x minus y. So y times x minus y. So it's this area plus this area that tells us what the difference of these two squares really is. So all in all, we have x times x minus y plus y times x minus y. So again, using this area model can help us understand what results here, which is this, but what can we factor out of the whole thing? As we talked about in our last video, yeah, x minus y. And we're left with x plus y. So the difference of two squares ends up being x plus y and x minus y. So really it's the square root of each piece. So the square root of x squared is x. The square root of y squared is y. So we have two parentheses here with x and y in both of them. One of them is the sum of them, and one of them is the difference of them. So that's kind of the why behind the what. A little bit there gives you some reasoning why that is. But let's look at some quick examples, and hopefully this will make a little bit more sense. X squared minus 16. What's the square root of x squared? X. And what's the square root of 16? 4. So it's going to be x and 4 in our parentheses. One of them is going to be x plus 4, and one of them is going to be x minus 4. So this factors in or is equivalent to this down here. Right? And that's precisely why we need to know our perfect squares. If this wasn't a perfect square, maybe it was like 15 or something, then we could still do this, but it'd be a lot more challenging. In this next one, x squared minus 1. What's the square root of x squared? X. So we're going to put that in both of these. What's the square root of 1? 1. One of them is going to be plus, one of them is going to be minus. So it's the difference of two squares set up there. All right, this next one is a little more challenging because we have this coefficient out in front of the x. So we actually need to rewrite this one first, because right now it's not the difference of two squares in terms of parentheses. So we want to rewrite this as something squared minus something squared. Or I guess you could leave it as 9 if you wanted to, but how can we rewrite 4x squared as something squared?
2x.
Yeah, 2x, right? Because 2 squared is 4, x squared is x squared, so it's the same thing, right? But we have it in this template that we want it to be in, something squared minus something squared. And this is going to be, 3, but you could just leave it in terms of 9 if you wanted to. But anyways, what's the square root of the first one? 2x, right? The square root of 2x squared is just 2x. And of course the square root of 9 over here was 3. So it's going to be 2x and 3 in our parentheses. Again, one of them is the sum and one of them is the difference. Okay? So in general, if we have something like a squared minus b squared, that's going to factor into a plus b, a minus b. Right? So, we've kind of already talked about x squared minus y squared, right? That's going to be x plus y, x minus y. What about x to the fourth minus y to the fourth, though? We haven't talked about difference of 2/4, right? We've talked about difference of 2 squares. But in reality, these are difference of 2 squares, which doesn't look like it right away. Because we can rewrite this first one as x squared squared. And this second one as what?
Y squared.
Yeah, y squared squared. So now it's the difference of 2 squares, right? It's this squared minus this squared. So then what's going to go in our parentheses?
X squared and Y squared.
Yeah, x squared and y squared. Again, one of them is going to be the sum, and one of them is going to be the difference. What's cool about this one is that we can actually take it one step further. Okay? We cannot factor the sum of two squares, right? The title of this lesson is difference of two squares. We can only factor the difference of two squares. So we cannot factor this one further. However, we can factor this one further. What does x squared minus y squared factor to? Yeah, x plus y, x minus y. So we can actually factor this further into x squared plus y squared, that stays the same, times, this one factors into x plus y times x minus y. So that's maybe a little bit different scenario that we haven't talked about yet, but we can still do the same thing. So just think about this template of if we have something squared minus something squared, we can actually factor it in this way. All right, so I want to give you a chance to practice before we get to this multiplication. So let me give you a couple here. X squared minus 25, x squared minus 121, 9x squared minus 64, and lastly 81x to the fourth minus 64, y to the fourth. Actually, I need to change this one. Let's see. We'll just make it y to the fourth. So take a second and try these four, and then we'll go over them here in just a second. All right, so let's take a look at these four. This first one factors into x plus 5, x minus 5. This one factors into x plus 11, x minus 11. This one up here factors into, let's see, we need to rewrite this first term here in 3x squared minus 64. Or you could rewrite that one as 8 squared if you wanted to. But either way, it factors into 3x plus 8, 3x minus 8. All right, and then this last one. We need to rewrite both of these as squares. So this first one is going to be 9x squared minus y squared. All right, let's just check it here. 9 squared is 81. X squared is x to the fourth. And then, of course, y squared is also y to the fourth. So now we've got it as something squared minus something squared. We can actually factor this into 9x squared plus y squared times 9x squared minus y squared. All right. Are we done at this point? Yeah, we can actually take this one step further. We cannot factor this one, but yet we can factor this one here. So, if we think about this one here, it's going to be 3x quantity squared minus y squared. So, in our next version of this, it's going to be 9x squared plus y squared times 3x plus y, 3x minus y will be our final version here. And that is as far as we can take it on this one. All right? So again, as long as you can write it as difference of two squares, you can factor it in this way: a plus b, a minus b, in terms of the general format. So we can actually use this idea of difference of two squares to do some mental math. For example, let's multiply 47 times 53 using mental math. That'd be kind of difficult if you just tried to think about the multiplication algorithm that you learned back in elementary school. But there's a different way. We can think about this as the difference of two squares setup, but in reverse. So instead of starting with difference of two squares and factoring it, we're going to think about starting with the factors and then moving towards the difference of two squares. Let me show you how this works. Instead of thinking this as 47, we can actually think of this as 50 minus 3. And then 53 we can think about not as 53, but as 50 plus 3. So this is, again, we're going in reverse order here. So we're starting with the difference of two squares setup in terms of the factors, and then we'll move into the difference of two squares. You could distribute this out if you wanted to, but really what we're going to end up with is the same thing that we had earlier, but in reverse. So 50 squared minus 3 squared is what we'll end up with. Okay, are y'all good so far there? Okay, 50 squared we can do in our head. What's 50 squared? 2,500 minus 9 is 2,490. So kind of an interesting strategy here. And I know we wrote it out here, but in simple cases like this or similar to this, you might be able to do it in your head, depending on how things go. So let's try one and see what we end up with here. How about 96 times 104? So take a second and see if you can try this mental math strategy with 96 times 104. So in this scenario, 100 is the kind of the midpoint of these two numbers. So we can do 100 minus 4 times 100 plus 4. Which is nice because we end up with 100 squared minus 4 squared. 100 squared, really you're just going to double the zeros, right? So it's going to be 1, 0, 0, 0, 0. So 10,000 minus 16 is what?
9,984.
9,984. So not too bad, right? Considering what we would have to do if we did the algorithm version of this and all that. And you might be able to do this in your head, but more importantly is understanding that we can use this algebra thing that we've been learning called difference of two squares to do number manipulation or calculation. And so that's one way to do that. So using that same idea, I want to have you think about this question. So which of these 5 products is greatest? So take a minute, see if you can figure out which is greatest without using a calculator, without multiplying these out using the algorithm. See if you can figure out which one of these is greatest. So let's talk about these 5, and the best scenario here is to actually rewrite each one of these as the difference of two squares. So what is the middle value of each of these? 82. So that makes it really challenging to think about which one's greatest because they all have the same sum, like 84 and 80 add up to 164, and so do the rest of these. So that's what makes it kind of challenging to think through. So each one of these has a middle value of 82. So let's rewrite each one of these as the difference of two squares. So this one would be 82 plus 2, 82 minus 2. So we can rewrite that as 82 squared minus 2 squared, right? Now let's think about, as we go through here, what's going to be the greatest, since they all have a middle value of 82, is whichever one subtracts the least amount, right? It's going to end up being the greatest output. So this one's going to be 82 plus 4, 82 minus 4. So 82 squared minus 4 squared. So which one's greater? This first one, right? We don't even have to calculate it, right? But we know it's greater because we're subtracting less. This one is going to be 82 plus 0, 82 minus 0. So 82 squared minus 0 squared. So we might have a conjecture, at least right now, that one's going to be the greatest. But let's continue on just to make sure. This one's going to be 82 plus 1, 82 minus 1. So 82 squared minus 1 squared. This one's 82 plus 8 and minus 8. So 82 squared minus 8 squared. So yes, as we said a minute ago, the one that subtracts the least is going to be the greatest. So it's actually going to be this one that is the greatest of all of them. And so Difference of two squares helped us figure that out. But more importantly, I want you to think about this as area. So think of each one of these as length times width. Okay? If the length plus the width for all of these add up to the same value, which is 164, that means they all have the same perimeter. All of these, right? All of these rectangles, think of them as rectangles. All of these rectangles have the same perimeter. So the question is, how do you maximize area given a specific perimeter? What shape do you make it? A square. All right, and we see that here, right? A square maximizes the area given a certain perimeter, which is kind of cool to think about. So anyways, that was one of our goals for today, this last one here, was to use difference of two squares to understand how to maximize area given a particular perimeter. We also talked about how to factor difference of two squares starting out, and then how to use those to multiply two numbers using mental math. So hopefully that gives you a good idea of difference of two squares and how it can be used in a number of different situations. So with that, that'll be the end of this video. In our next video, we'll talk about how to use what we've learned about factoring to help us graph polynomials.